Okay, so here's this Yosemite rockfall problem. Number 1 says to determine the initial angle of the projectile's velocity. So this rock, you can kind of visualize it. The rock kind of slides down this rock shelf, and then right here, the rock becomes airborne. It becomes a projectile. So what you do is you draw a tangent line. You go boom. In fact, let me erase some of this. I want to clean this up so it looks real nice. So we don't need that. We'll erase that. Okay, so the rock becomes a projectile right here. So what you do is you draw a tangent line, and so there's a tangent line to the trajectory. Now, is this velocity, so this black vector here represents v initial. Is that velocity perfectly x? No. Is it perfectly y? No. It has x component, which I'm going to write down as vx, and it has y component. There's vy. And then you get a protractor out, and you should have found this angle to be about 45 degrees. Okay, so that's number 1. Easiest question. All right, number 2 says to write an equation for the horizontal component of the rock's motion. So this takes you to the kinematics. Now for the x direction, you may have forgotten how many equations are there for the x direction. When you're dealing with a projectile motion sort of problem, how many equations are there? The four kinematics reduce to 1. Okay? That was bad. It reduces to 1. And why is that? Look, what's the acceleration for the x direction for projectile motion? 0. And dude, what's the reason for that? Why is the acceleration 0? Because this x velocity right here stays what? Constant. The x velocity does not change. Now, the y velocity does change, and that's because we have acceleration in the y, which is gravity, which is negative 9.8. Okay? Now, so for number 2 on the worksheet says, write an equation for the horizontal component of the rock's motion. Okay, so x, the only x equation for the horizontal direction is vx times t, but let's be a little more clear. What do we mean by vx? Let's put that in terms of v initial. So what is vx here going to be? Cosine 45 v initial. Put it in terms of v initial, the black vector there. So let's rewrite this one more time. This is going to be cosine 45 v initial times t. So this is the equation for the horizontal direction, right? And by the way, what do we mean by x? X is the horizontal displacement from here, right? This is where the rock starts horizontally, right there, and then it lands right there. So what is this x going to be? Roughly about what? You're approximating, but roughly about what? 325 meters. That's the x. Okay, now number 3 says to write an equation for the vertical component of the rock's motion. So use the first kinematic. It's the most commonly used kinematic. Y equals 1/2 g t squared plus vy initial t. Now what can we say about vy initial? What is vy initial going to be? This negative, y negative. It points down. So vy initial is negative sine 45 v initial. So I'm going to rewrite this again. Y equals 1/2 gt squared plus, okay, so vy initial is negative sine 45 v initial times t. Okay? Negative because it points down. Now, what's this y value going to be? What's the y displacement? This y displacement right here is, so let's see, let's figure it out. The y displacement, so the projectile starts there and ends there. Okay, so approximately, let's just call this 1775 meters, and then this will be 1275. So what is this y displacement going to be? 500. Careful though, careful. Negative. Why negative 500? Well, did the projectile go down vertically or up vertically? Down. Down is negative, up is positive. That's negative 500. And then be aware, what's gravity? Negative 9.8. Don't forget the negative. Okay? Now, look. These two equations right here, these two equations have two things in common. What do these guys have in common? T and V initial, right? If you have two equations and two unknowns, can you solve it? Yeah. So here's where the algebra gets kind of crazy. What you're going to do is you're going to substitute these equations together, and let me be even more clear. Take this equation here. T equals x over cosine 45 V initial, right? I just rearranged it. Plug that in there and there. The algebra is going to get kind of ba-boom. It's going to be a right? So it's going to be some algebra. Work it slowly. One thing you're going to find is that you're going to get sine over cosine. What is sine over cosine? Tangent. When you take this right here, and plug it in there, you're going to have sine over cosine, and that's tangent. That'll be tangent 45. So that'll simplify it. So then you can solve for V initial, which is the answer to number 4. And then number 5 wants the time. So look, once you know V initial, just take this equation, so number 5, take this equation right here, solve this baby right here for what? For time, right? Once you know V initial. In number 4, you got V initial. Then take this equation here, solve it for time. And then last question, what are you laughing at? Okay. Can I erase this? You guys copy that? Okay. You like this, don't you? It's physics. How could you not? Okay, for number 6, look. Number 6 is talking about right here, right? Right here. When the projectile lands, so what does it say? Calculate the velocity of the rock as it strikes the ground. The answer is not 0. I love it when kids say that. When the rock hits the ground, it stops. 0. No. Have I told you that before? Huh? I'm a little stuffy. Yeah, do I sound different? I got a little stuffy in my nose. Okay, so how do we find the velocity right before it hits? Well, look. Right when the rock hits the ground, does it have an x velocity? Yes. Does it have a y velocity? Yes. The answer that number 6 is asking for is the hypotenuse, right? It's a little bit of vector work, right? Notice, put Vx and Vy tip to tail. The resultant vector goes from the tail of the first to the tip of the last. The question is asking for that, for V initial. How do you get V initial? Well, you first have to figure out what? You first have to find Vx and Vy. Vx is going to be easier because it doesn't change. All you got to do is go like this. To get Vx, just do that. Boom, you got it. But then Vy, hey man, is your Vy going to be that? No, that was the initial Vy. What happens to Vy as the rock falls? It gets bigger, bigger, bigger in the negative direction. So you got to calculate that with a kinematic. Does that make sense? So find Vy. Once you have Vx and Vy, call up your friend. Who? Call up your friend Pythagoras and say, hey Pythagoras, work the magic and get that, right? Do Pythagorean theorem. and then solve for the angle. Don't forget about the angle, right? Boom. All right, so that's how you do it. You like this, don't you? All right, let's talk about chapter 6 now. Any questions on this?